and welcome to the Big Bang. Mass transfer problem statements contain a lot of information, but if you know how to interpret and categorize the information as known, unknown, assumption, boundary condition, or initial condition, then the problem becomes much easier to solve. There are 5 general steps to solving a mass transfer problem. First, make and label your engineering schematic. What are the fixed coordinates or coordinate system? Rectangular, spherical, or cylindrical? Where is the source? Is it constant? Where is the sink? The source and sink help you determine the direction of flux. What are the given boundary conditions? Are they concentrations or fluxes? Make sure to note all the units. You will never regret it. Second, write down all your knowns and unknowns and convert them into the same units. Third, list your assumptions considering geometry, steady state, direction of flux, convection, homogeneous reactions, and heterogeneous reactions. Remember that Fick's first law only applies to isothermal, isobaric, binary, dilute solutions. Fourth, write your boundary conditions. You need 2 boundary conditions for a problem at steady state. You need 2 boundary conditions plus an initial condition if you are dealing with unsteady state. Fifth, write your differential equation of change for mass transfer. In other words, perform a mass balance. Apply assumptions from step 3 to cross out terms that don't apply. Consider what unknown you are solving for. Some of the goals of performing a material balance is to determine flux at a boundary, concentration at a boundary or point away from the boundary, the concentration profile of the solution, Ca of xt, or the reaction rate at a boundary. You will likely need to consider Fick's first law in the context of the mass balance as well. You apply your assumption to Fick's first law and then plug it into the mass balance to solve for the flux or heterogeneous reactions at the boundary. If the flux or heterogeneous boundary condition is known, you can use Fick's first law to find the missing concentration. If you want to find the concentration profile of the solution, you must separate and integrate the differential equation of mass transfer using the boundary conditions as the integration bounds. In summary, the 5 steps to solving a problem in mass transfer are: 1. Draw your engineering schematic. 2. List the knowns and unknowns and categorize them. 3. List your assumptions. 4. Note the boundary and initial conditions. And 5. Perform a mass balance. Hopefully this video will make tackling those mass transfer problems a lot easier. Thanks for watching, and I'll see you in the next video.